Hi folks, we're going to take a look at this question here from the last lesson. So we have a soccer goalie kicking the ball 1 meter above the ground. The ball reaches a maximum height of 21 meters after 2 seconds, and they tell us to model the height of the ball with respect to time. Right? Now, when they're asking us for a model, the ideal model would be an analytical one, in other words, an equation. But what we're going to see here is that drawing a graphical model will be helpful in coming up with that equation. All right, so let me create a Cartesian plane here. And what they want us to model is the height of the ball with respect to time. So the height with respect to time. All right, now you'll notice the way I drew my Cartesian plane, I left room only for positive values because that's all I'm interested in. Time is always positive. And here, they're not specifically saying that we're measuring height from the ground, but that's an assumption that we make unless it's otherwise specified. So I'm only interested in positive values of height also. All right, so let's put down the information on the graph that we know. So we know that at the start, the goalie kicks the ball 1 meter above the ground. So at the start, times 0, the height of the ball is equal to 1. All right, so then it goes up, reaches a maximum height of 21, and then comes back down. And we know that that's going to create a parabola. Okay, so after 2 seconds, the height of the ball is 21 meters. Okay, so in other words, what they've given us is they've given us the vertex of this parabola. All right, and since we were given information about the vertex, it makes sense to use the vertex form of the parabola. Okay, so instead of y and x, I'll use h and t, okay, because those are more variables that are more appropriate for this scenario. So what we have here is we have h is equal to, well, we don't know the a value yet, okay, but we do know the h and k value, okay, because in the equation of in the vertex form of the parabola. All right, now here, got to be careful because h is representing height. I'm talking about that h value. So on the side, if we remember what, when we're using x minus h squared plus k. So this value here that is subtracted from the x variable represents the x component of the vertex. So it's going to be t minus 2 squared plus the y value of the vertex, which is 21. All right. So in other words, the only thing left to calculate is this a value. So how are we going to do that? Well, it means we need another piece of information. And luckily, we have another piece of information because we have the y-intercept of this function. We know that at time 0, the height is equal to 1. So I'm just going to take those values, input them into my equation. Okay. So height of 1 when the t value is equal to 0. And lo and behold, I'm just left with an equation where the only unknown is a. So we can solve for that. All right, so I can take this 21, bring it to the other side. So 1 minus 21 is negative 20. Okay, here, 0 minus 2 is negative 2 squared is positive 4, so 4a. So the a value is going to be negative 20 over 4, or negative 5. All right, so what we have as our model here is h equals negative 5, t minus 2 squared plus 21, okay, where h is the height in meters, okay, and t is the time in seconds. Now, anytime we're creating an equation, we really should be specifying what our variables represent. All right, and by the way, I don't think we should be too surprised that our a value is negative since we have a downward facing parabola. Okay, so let's just recap this because this is a pretty common type of problem. So if they're asking to find the equation of a parabola and they give you information about the vertex, it makes sense to use vertex form. So you could take the h, k values of the vertex, input them into your equation, and then the only thing left to calculate is the a value. All right, and the way you do that is to find another point on your graph other than the vertex, input it in, and solve for a. Okay, that's it for this one.